For this video, we're going to be revisiting some concepts that you learned in coordinate algebra. We're going to be looking at what we call rigid motions. Now, rigid motions are what they sound like. If you know what the word rigid means, it means something that is still or strong or doesn't change. And we're going to be talking about these transformations in terms of being rigid motions. So let's do a quick reminder on what each of these are. For rotations, rotations are when we take a figure and we turn it around a center of rotation. Now, the thing about this is we can turn the figure any way we want to, but the figure isn't going to change. It's still going to have the same side lengths, still going to have the same angles. Our one-word explanation of a rotation is generally a turn. For reflections, this is where we give a mirror image of the figure. Like you may flip it over the x-axis or the y-axis. So we talk about reflections as being a flip. When you reflect a figure, you do not change anything about it except its position. It still has the same side lengths and it still has the same angles. Our last one is translations, and those are movements in a direction, left, right, up, down, diagonally, any type of a movement. We generally refer to that as a slide. And when we slide a figure or translate a figure, again, we are not changing anything about that figure except for its location. The sides are still the same, and the angles are still the same. The reason that I'm putting so much focus on that sameness is because we're going to be talking about figures being congruent. Any figures that have been translated, rotated, or reflected, we can be absolutely sure that they are congruent. So our definition we're going to be working with this year of congruent is two figures are congruent if and only if all corresponding angles are congruent and all corresponding sides are congruent. So let's talk about that term corresponding. When we talk about corresponding, we talk about the resulting angle after the transformation has taken place. So I've given you two triangles here that have had a reflection and a translation done. So we'll start with the triangle on the left, and let's call that triangle A, B, C. Now, when a figure is translated or reflected, it makes another figure, but that figure has not changed. All it's changed is that it now is flipped a different direction and it has moved up. So we're going to call this one D, E, F. Now, when we talk about corresponding sides, we talk about the side in the original image, or the pre-image, as you probably learned it last year, and the side that it is now in the image. So let's look at AB. We'll put a mark in here. AB, after we have reflected and translated the figure, corresponds to side FE. We know that those two sides are congruent. BC, I'm going to put two marks here, corresponds to DE, and AC corresponds to DF. We write that as AC is congruent to FD. And we know that that's true because of the reflection and translation that's taken place. Our corresponding angles, A corresponds to F. We already know that B corresponds to E. And C corresponds to D. So now we look at this and we think about how to say that these two triangles are congruent. And to do that, we write what's called a congruence statement. Now, the thing with a congruence statement is that you have to put the corresponding angles and sides in the same order for both of your triangles. So let's name our triangle on the left A, B, C. Now, we're going to name our triangle on the right based on the corresponding angles. Angle A corresponds to angle F, so we're going to put it first. Angle B corresponds to angle D, so we put it second. And angle E corresponds to angle B, so we put E last. And that's a congruence statement to ensure that you are correctly saying that the triangles are congruent. If any of these are out of order, then the congruence statement is incorrect. Now, it's time to go answer your questions.